Hello, my name is Ron Kramer, and I'm an online instructor for Dominican University. Tonight I'd like to share with you a course called Exploring with Squares and Cubes. And this book was published in 1989. It was about 10 years of collecting experiments that my students did with squares and cubes to study area and volume. And it's based on the premise that mathematics is a branch of science. And in these activities, your students will be exploring mathematical questions, conducting experiments with manipulatives, and recording and posting resulting solutions, organizing and analyzing collected data, comparing, sorting, and classifying. And they will be evaluating data, removing duplicate solutions and errors, creating a solution set. And they'll be discovering patterns in the organized data, often revealing missing solutions. And finally, extrapolating and predicting the size of the next solution set based on previous patterns. And these verbs describe exactly what a scientist does. And that's what your students will be doing as they go through the activities in this course. The first experiment is a very simple one, just seeing how many different ways you can connect two squares. There's one way to do it. My students would say, well, that's another way. I says, well, if I can turn yours so it looks like mine, it's not a new solution. There's only one way you can connect two. We explored 3, and there's 2 ways you can connect 3. There are 5 ways you can connect 4 squares, and so then I asked them how many ways you could connect 5 squares, and they came up with 12 unique solutions, and they're called pentominoes, and these are available commercially in plastic. The next question I asked them was, how many ways could you combine 6 squares? And these are hexamonos. It turns out that there's 35 ways to do it. Now, if you take this course, do not tell your children how many ways to look for. Let them discover it on their own. It's very important. So then I asked them, how many of these could you fold up into make perfect cubes? So this cross is one way to make a perfect cube. Then I asked them, well, how many ways can you combine cubes? How many different ways can you do that? And they found there was only one way to combine 3 cubes that's unique. And it turns out that there were 6 ways to combine 4 cubes. And so they began exploring how many ways they could stack these. And this becomes a puzzle called Soma. With these, I asked them how many different squares could they make, and they came up with this many solutions. And they were published in this book. And a teacher in Enid, Oklahoma bought this book, and her students found more ways to do it. And they wrote me saying, are these new? And I said, yes, they are, and I'll put them in the 2nd edition. Well, they contributed new ideas to this book, and it made the headlines in Enid, Oklahoma's newspaper, as Students Outsmart Mathematics book. And that was interesting because here was a group of 5th grade mathematicians in one part of the country helping my 3rd graders in this part of the country solve the same problem. So I'd encourage you to take this course if you're interested in studying area and volume. Thank you.